Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a very good example for finding the domain of a logarithmic function from the basics to the advanced level. The logarithmic function is a logarithm to the base of gx, which is the function of x itself, of natural logarithm of fx, log to the base gx of ln function x, that is equal to function hx. We have to find the domain of it. For finding the domain, we require what ln fx is fx domain, and then what is the logarithm to the base gx domain, so that we will find out the domain of hx. It's a very good example, and it revolves around the concepts of logarithm, which are essential for the aspirants of higher mathematics examinations like CBSE, IIT JEE, CSIR Net Mathematics and Maths Olympiad. And we have to find out the domain, and we have to do the multiple choice question. Whether A is correct or B is correct or C is correct or D is correct. 4 alternatives are given. It's a IIT JEE level multiple choice question. Please pay attention to the concepts, and if this type of question comes in the examination, you will be able to solve it very easily. Now, let us try to write the question and answer it carefully with the using the concepts of logarithm. What is the question given? Find domain of logarithm to the base gx of ln fx, which is equal to hx. This is what is given to us, where fx and gx are the functions of x and hx is also a function of x. Now, let's go for the solution. Step by step, let us see. Now, let us take one general logarithm, log p to the base q. If it is taken, how we will define it? This is definable if A, or rather we will call it as property 1. The base q is not equal to 1, and second property is q should be greater than 0, and third property is logarithm of p should not be any negative value. That means p should be greater than 0. Please remember these. These are very important concepts. These three concepts are very important, very important. Please remember them. Because if q is equal to 1, it will be undefined at q is equal to 1. The reason. If q is not positive, if it is negative, then no real value. This logarithm will not have a real value. And why p should be greater than 0? Because for real values, when we talk about the values on real line, log should be positive. These are the three conditions which are to be fulfilled for defining a logarithm on a real line. Now, we will apply these three conditions to the given problem. What is the problem given here? Log of gx of ln function x. Let us try to analyze this one. The logarithm inside the logarithm. It is a natural logarithm. Ln fx is equal to log to the base e. Natural logarithm is base e of function x. Compare it with log p to the base q, which we have just now discussed. What it says? Q should be greater than 0 and q should not be equal to 1 and p should be greater than 0. Now, from this what happens? When we compare these two, q should be greater than 0. That means E, which is 2.718, it is already greater than 0 and it is not equal to 0, not equal to 1. Sorry. That means these two conditions are fulfilled. That base is correct. Now, for p to be log p to the base e should be definable, will be definable when p is greater than 0. That implies function x should be greater than 0. This is the first step. Step 1. Step 1 says function x, because already base e is already satisfying this greater than 0 and not equal to 1. Hence, the only condition we get from this step 1 is from the internal logarithm of natural logarithm, function x should be greater than 0. Now, next comes second step, outer logarithm. Logarithm to the base gx of ln function x to be definable compare it with log, we will write in other color, log p to the base q. That implies q is compared with gx, gx should be greater than 0 and gx should not be equal to 1. Now what happens to fx? P means ln, this is p here, just see, this is p here. P in the previous one is different, P here is different. It is outer logarithm we are taking. P should be greater than 0. That means P is ln function x should be greater than 0. When ln function x should be greater than 0 means ln 1 is 0. It should be greater than 0. The ln function x, which implies function x should be greater than 1. Just see, an additional logarithm made function x should be greater than 0 here we have got. But this is not the ultimate, it is only for the inner logarithm, natural logarithm to exist. But existing of natural logarithm itself is not sufficient for the whole hx to be existing. For whole hx to be existing, function x should be greater than 1. That implies from both the conditions, what we have got the answer is that hx to exist, hx domain will be for existing function x should be greater than 1. Second, gx should be greater than 0. Third is gx should not be equal to 1. Now, let us find out the correct multiple choice. Function x is greater than 0, gx is greater than 0. It is not correct. It is wrong. Function x is greater than 1, gx is greater than 0. That is fully not defined. Hence, we will take it as partially right, and partially right answers need not be taken. It is wrong. Function x is greater than 1, gx is greater than 0, gx is not equal to 1. This is the correct answer. This is the right answer. And function x is greater than 0 and gx is not equal to 1. It is also wrong answer. That means the final answer is C, which says function x is greater than 1, gx is greater than 0 and gx is not equal to 1. For this is the domain of, this is the domain of log gx ln function x. This is the answer. Answer is G. Answer is C. Function x should be greater than 1, gx should be greater than 0 and gx is not equal to 1. With this, I wanted to conclude this lecture. Even though it's a small problem, it's a tricky problem. You should know the concept that for log p to the base q to exist, it implies p should be greater than 0 and q should be greater than 0 and q should not be equal to 1. From this, we have derived the above problem. In the above problem, function x is greater than 1 because it has come. The reason is that a natural logarithm is embedded within the regular logarithm. With this, I wanted to conclude this lecture. Thank you for listening to me. Thank you for viewing my lecture. Best of luck to everybody. If you feel there is a improvement in your knowledge, you gained something out of this lecture, please hype this lecture, share this lecture and share my channel details to the known people and subscribe to my channel and encourage people to subscribe to my channel Maths and Science by IITian. I have released many videos, more than 350 videos on mathematics. Please see them. All are concept based and doing the questions, problems, so that you will understand different concepts embedded in the problems. Along with doing the problems, instead of reading it as a theory, mathematics can be understood only by doing it, not by reading it. Please try to maximize your knowledge by doing the mathematics along with me. Please see other videos also, and best of luck to everybody. Thank you for seeing this lecture.